Hey guys, this video is about solving a problem from chapter 15. And this problem is an application about spur gears. The definition of spur gears on Google is like the spur gears are the most easily visualized common gears that transmit motion between two parallel shafts. Before seeing the problem, there are some formulas for this problem that we need. The first formula gonna be capital P equals to N over D. The capital P in this formula means the diameter pitch and the unit is teeth per inch. The N means the number of teeth and the D means the pitch diameter. The second formula is Fr equals to Ft times tangent degree. The force between mating teeth can be resolved at the pitch point, P is in the figure, into two components. Number 1, tangential component Ft, which, when multiplied by the pitch line velocity, accounts for the power transmitted. Number 2, ratio component Fr, which does not work but tends to push the gear apart. So here is a question. The 18-tooth pinion in figure 15.25 is driven 800 RPM by a motor that delivers 20 pounds-inch of torque. The gears provide a double reduction in speed, with output taken from the 36-tooth gear. Both the 6-pitch and 9-pitch gears have a 25-degree pressure angle. Neglecting the small friction loss in the gears and bearings, determine the radial loads applied to countershaft bearing A and B. Sketch the countershaft as a free body in equilibrium. On the right part, this is a diagram of this question. I will give you some seconds to take a look at this paragraph. Next, I underlined the known conditions, important keywords and data in the topic. We will use this data to analyze and solve the problem in the next process. At the same time, I also stressed the requirements of the topic. This step is crucial for such a long topic. Before calculating the data, we first need to draw a free body diagram with detailed information, which can help us sort out the known conditions, find the force relationship between various parts, and filter out some interference data. In this diagram, I listed two gears arranged parallel. I call them big gears on the left and small gears on the right. We first need to find out the radius of the two gears, and then find out the force acting on the two gears through the force analysis diagram. To facilitate understanding, I think the four forces are named F large 1, F large 2, F small 1, and F small 2. Finally, there are also four forces on the two driving points of A and B, namely A horizontal, A vertical, B horizontal, and B vertical. After analyzing the free body diagram, we can see that number 1, figuring out the gear dimensions. Number 2, identifying force components between the gears. And number 3, how to solve for the forces using a free body diagram for the gears. Also, we can do some assumptions. 1. The gears mesh along their pitch circles. 2. Friction losses in gears and bearings can be neglected. This is a given. 3. The shafts are all parallel. 4. All the gears' radial and tangential load is transferred at the pitch point. 5. Bending deflection of the countershaft is negligible. 6. Gear face width and bearing widths are negligible relative to countershaft length. 7. The gear are rigidly connected to their shaft. Then it's time to solve the problem. From the free body diagram, we can see that the force large 1 equals to 20 pounds inch over 1 inch equals to 20 pounds. the force large 2 equals to 20 pounds times tangent 25 degree equals to 9.33 pound. The diameter of the large gear equals to N over P equals to 7.11 inch, and the diameter of the small gear equals to N over P equals to 4 inch. The force of the small gear 3 equals to 20 pounds times 7.11 inch over 4 inch equals to 35.55 pound. This is a ratio. And the force of the small 4 equals to 35.55 times tangent 25 degree equals to 1658 pound. Then step 1, to figuring out the pitch diameter of input pinion. D equals to N over P equals to 18 over 9 equals to 2 inch. Step 2, about the horizontal plane. The sigma MA equals to 0. 20 pound times 2 inch plus 35.55 pound times 2 plus 8 inch minus BH times 2 plus 8 plus 2 inch equals to 0. From this equation, we can figure out the BH equals to 32.96 pound. Sigma F equals to 0. The 20 pound plus 35.55 pounds minus 32.96 pounds minus AH equals to 0. From this equation, we can figure out the AH equals to 22.95 pound. Step 3, the vertical plane. Sigma MA equals to 0. 9.33 pound times 2 inch minus 16.58 pound times 10 inch plus B vertical times 10 plus 2 plus 2 inch equals to 0. From this equation, we can figure out the B vertical equals to 12.26 pound. The sigma F equals to 0. Negative 9.33 pounds plus 16.58 pounds minus 12.26 pounds plus AV equals to 0. From this equation, we can figure out that the A horizontal equals to 5.0 pound. Step 4 is about calculating the A radium and the B radium, which equals to 23.14 pound and 35.17 pound respectively. That's all of this problem solving. Thank you.